and welcome to today's class. Today I want us to look at the 2025 WAEC Physics Practical, precisely question number 3. And the question number 3, of course, we all know that number 3 is usually electricity. But the funny part of the whole thing is that students run away from electricity experiment. That is why I am bringing it up now as the first experiment now. Instead of starting from number 1, I am starting from number 3 down to 1. Now, this, of course, this is alternative A. Why alternative A? Some are still confused between alternative A and alternative B. Now, I want to tell you that alternative A and B are two different questions, two different exam questions. Now, this one is for alternative A. Alternative B might be different from this or something similar to this. Alternative B also are written by those schools that registered more than 80 science students. If your school registered more than 80 science students, that means, let's say 100. The first 45 or the first 60 will write alternative A, while the other ones will write alternative B. Or if the school registered up to 200 science students, maybe 90 or 120, because it goes by 15, multiple of 15, will write alternative A, and the other ones will write alternative B. So for those writing alternative A, we go. But for those who may be writing alternative B, please stay with me in this channel. Once the instruction for alternative B comes up, I will still make video for alternative B. Now, let's start. But before we start, please, if you have not subscribed to my channel, do me this favor, hit the subscribe button, turn on your notification bell so that the moment I upload new videos, you will be notified. Do not fail to share this video with your friends. A lot of students are finding it difficult to do this. That is why I have come out with this to help you simplify this to the barest minimum so that you can do this. Please, for those who may not have the equipment in their school, join me towards the end of this lesson. I will tell you the easiest method of getting the readings if you don't have these equipment in your school. Now let us go. Now we have this setup. We have from P to Q is a potentiometer wire. We have this is the voltmeter. Of course, from the items required by WAEC, they requested 2 volts voltmeter. That is voltmeter that reads from 0 to 2 volts. Now we have this ammeter here. It reads from 0 to 1 ampere. We have other necessary equipment here. This is a rheostat or the variable resistor. This is our jockey. This is the key or the switch. This is the EMF or the battery rack. Now this is a standard resistor. Remember, they requested that a resistor be produced, and that they gave the value. The value is 1 ohm, but they say it must be maxed and labeled. So who knows? They might ask you to find the value of RX from your question. Now we have this one. The first one says, connect the circuit as shown in the diagram above, which is always the first thing. Now they say, with the key open, adjust the rheostat until maximum current and the voltage are obtained. Maximum current and voltage are obtained. Read and record the value of that current and the voltage that have been obtained. Record them as I0 and V0. When the jockey is not making contact with the potentiometer wire P, yes, so after the whole connection, adjust the rheostat so that you can obtain the maximum current and the maximum voltage. Once you do that, please, on no condition should you adjust the rheostat again. Keep that rheostat steady until the end of the experiment. Now, the second instruction says, using the jockey, make a a contact with the potentiometer wire PQ at a point J such that PJ is equal to L, which is equal to 10 centimeter. Read and record the current I and the corresponding value of the voltage V. Evaluate I inverse and the V inverse. Now we have this one here, number 4. Repeat the procedure for 5 other values of Pj from here to here equals 20, 30, 40, 50, and 60 centimeter respectively, and evaluate I inverse, V inverse, and V inverse respectively. Please, for this exam, I will do 10, 20, 30, 40, 50, 60, 70, 80, and 90. In case they didn't start from 10, if they are jumping, maybe let's say they can say 20, 40, 60, 80, 100. You can still obtain that. Okay. And then they said, plot a graph with V on the vertical axis and I on the horizontal axis. V inverse on the vertical axis, I inverse on the horizontal axis. Starting both axes from the origin, 0, 0. Determine the slope S of the graph. State 2 precautions taken to ensure accurate results. State 2 advantages of lead acid accumulator over dry Leclanche cell. Now, having read all these things, let us perform the experiment. First, I will show you all these things, how they are, how you connect them, and then at the end of the day, we will generate our reading. Please do not be in a haste to leave. Wait, I am going to show you step by step how to plot the graph. This is our ammeter that reads from 0 to 1 ampere. This is the voltmeter that reads from 0 to 2 volts. Now, this is our potentiometer. This potentiometer, this is the first terminal, and then remember it is long, it is 100. So this is 90. Now this is the hundreds. This is 99 here. After 99, 100. So the length of this potentiometer is 100. Now this is the battery rack. This battery rack contains 2 batteries. Remember they said the 2 batteries. One is positive, the other side is negative. Now this is the key. The key is open. We can have, this is a 2-way switch. You can connect here and close here, or you connect here and close this aspect. Now this is our jockey. Of course, this jockey, this is the only terminal it has. The other terminal here, when you now make contact here, it completes the circuit. Now the next thing is the rheostat. So this is our rheostat. Of course, the value of rheostat is 100 ohms, and then the current is 1 ampere. Now this is we have it has this and this as the terminal, or you can also have this. That means you can connect either here and here, or you connect here and here. So these are the terminals. Now we start our connection with the diagram on the screen here. We start the connection. Okay, I am done with the connection. If you look at this, this is the one end of the potentiometer wire, which is a P. From P, if you look at that diagram, we have from P, we connect the voltmeter. Of course, this is the voltmeter. Remember, of course, let me explain this why I cross this. This one should have come here, why this one here? But if you do that, the pointer would deflect negative, would deflect below 0. Because of that, the only way to correct that is by interchanging. That's why I interchange this. Now, if we come to this other end, from here, from this other end, we have, let me come down, we have the standard resistor. This is already is a P, but I will label it arrow X that day. So we have here, this is from there to battery, from battery to our ammeter, from ammeter down to the rheostat. Now from the rheostat, watch it, from this one is on its own. So from the rheostat straight to the key. Remember, once the connection is going on, your key must be open. You drop it from here to the other end of the terminal. Now this third wire here is the jockey. Remember, it must be a longer wire, so that of at least up to or more than 100 centimeter, so that it can be able to move from here to the other end of the potentiometer. Okay, now having done this, let us start our reading. Now I have brought the 2 meters together. We have the ammeter and the voltmeter. Now we start. Remember, they said after connection, close the key. Now, if you close the key, observe the 2 of them, the voltmeter and the ammeter. Now, when you observe them, they are not reading anything. Okay. Now, they said adjust. Now, when we now adjust, now I have brought the thing together. I have brought both the key, the rheostat, this and this together. Now, I will close. Once I close the key, remember this and this. So, I will close here. Now, if I close here, the voltmeter also reading low voltage. Remember, they said adjust your rheostat until you obtain a maximum current. Now, how do we adjust? Now, we adjust using this slider. Now, as you adjust it, you see that both the ammeter and the voltmeter are reading. Now, assuming of course, I cannot adjust further. I can't adjust further, because if you move it like this, you see it. Okay, now I cannot. This is the maximum current I can obtain. Now, if you look at the maximum current, the ammeter is reading at its maximum value, which is 0.2, of course, 0.24, 0.6. I naught will give us 0.26, while V, if you look at V, let me place it properly so that you can read it. Now, if you look at V, from here to here is 10 calibrations. So, 0.4 divided by 10 will give us 0.04. So, each line is 0.04. It means that the V will give us is 0.32, something close to 0.32. It's 1.48 volts, while that of the current will give us 0.26 ampere. Okay, now the next thing now is to start. So I will show us what we are doing. Now we start with the first one. First, close the key. If you close the key, it will deflect. Now tap at 10. When you tap at 10, you read that the current, the voltage, there is 1.32, while current is 0.22. We'll leave it, open the key, and then now we close the key back and then tap at 20. If you tap at 20, the voltage will read 1.2, current will read 0.24. We'll leave it. Now we close the key again and then tap our jockey at 30. Now if you tap your jockey at 30, current will reach Okay, we'll read it when it is steady. Okay, voltage will now read voltage will read 1.24, while ammeter is reading 0.3. We remove it. Now we close the key again. If we close the key, we'll tap our jockey at 40. So if we tap it at 40, current voltage will now read 1. Now we have, so the current is given, voltage is given us, if you look at it, it's in between. That means 1.1 to 1.14. So it's giving us 1.12. 1.12. Check it. You can pause this video and read it. So it's 1.12, while current is 0.31. Now we remove the key. Now we close the key again. Now I'll tap at 50. So if you tap at 50, this one will give us 1.04 for the voltage, while the ammeter is 3.4. Now we close the key again. Tap at 60. So if we tap at 60, the voltage keep dropping. The voltage here now is 0.84889296. 0.96, while the ammeter is reading 3.8. 0.38, please. 0.38. We close the key again. Tap at 70. I will complete it. If you tap at 70, the voltage will give us 0.84, while the current will give us 0.370. At 70, at 70, the ammeter reading, of course, ammeter reading is 0.4, while the voltmeter reading is 0.86, because it's in between. Now we put the key again and then read for that of 80. Now for that of 80, ammeter reading is if you look at it, it's in between. Okay, 0.44, while the voltmeter reading is 0.69. So we take it as 0.69, and this other one is 0.44. Now at 90, it is 0.48, 0.4892. I mean 0.93. Sorry, 0.53, please. 0.53 against current, which is 0.1234. That means 0.49, 0.93, 0.53, and 0.49. Now we are done with our reading, and let us see what we have gotten so far. So this is the table we have. But then if you notice here, there is because what WAEC mark is trend. They don't mark exact figure. If you look at the current, our current was, in fact, the first one gave us 0.22. We have the trend there is an increasing trend. So as the length is increasing, the current increases also. Remember, your DP, you must be consistent with your DP. So all these values recorded from a device must be recorded to at least 2 dp. Now here, if you notice this thing now, the first voltage gave us 1.3. Now second one, it dropped. So between this and between 1, 2, 3, even this one, the thing is fluctuating. Voltage, there is voltage fluctuation here. Remember what, like I said earlier, WAEC doesn't mark values, they mark trend. So you can adjust, yes, you can adjust these values. Since you have noticed the trend here, as the length is increasing, current increases, then voltage, if you look at this is the highest here, 1.3, and then this is the least. So it is on the decreasing trend. Since it's on the decreasing trend, if you plot this, I can actually plot this. If I plot it, these values will scatter. So in order to eliminate that scatter, we can as well adjust this. Yes, we adjust this. So since this one is 1.32, we can leave it. Maybe this one, we can make this one 1.30. If we make it 1.30, then we can make this one 1.24. We can leave it at 1.24. If we leave it at 1.24 here, that means here we can actually leave this one at 1.20. If we leave it at 1.20, then I think it has balanced now with this adjustment. Now it has balanced. That means this is on the decreasing trend. It is on the decreasing trend. So it will give you a decreasing value, because here is 1.20, here is 1.14. After 1.14, we have 0.96, 0.86, 0.69, 0.5. So actually, where the problem, where we have a little issue is just somewhere here. Having rectified this, remember I will adjust it here. If I adjust it on this column, then we plot straight. Okay. Now we plot our graph. This is the graph page we have done. The first thing is to put your axis. Now remember, the question says plot a graph of V inverse on the vertical axis against I inverse on the horizontal axis. So the first thing you do is that you place your horizontal or your vertical. Since here is minus I raised to power minus 1 or I inverse, so we put it here I raised to power minus 1. As you are putting it, endeavor to put your SI unit, meaning per ohm, per ampere, or A raised to power minus 1. After that, the next one is your vertical axis, V inverse, which is V raised to power minus 1. You put it there, the SI unit. Very important. On no condition should you forget the SI unit. Now, after that, remember they said start from the origin 00. It has its own mark. That means you come here 0, 0. You put it there. So we have this, Make sure all these are indicated. And after that, the next thing now is to choose your scale. How do we choose our scale? The scales are chosen from the results we have. Now the results we have, I will remove this and then show it on the screen. Now the results we have, from the results, the least we have on the V-axis is 0.758, while the highest is 1.88 or 89, as the case may be. You label your axis. With this now, we can now label here to be, we can have here as 0.2, 0.4, 0.6. That means here is 0.1. That is what it means. 0.3 here, 0.5 here. You continue. 0.7, 0.8, 0.9, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8. Somewhere here is 1.9. So remember, now on the horizontal axis, remember there, the rule is that the highest score must occupy at least 2/3 of your graph. So must occupy somewhere here. So looking at what we have the least is 2.04, while the highest is 4.5. So we can say, let here be 1, let here be 2, let here be 3, let here be 4, 5, 6, 7. So what it means that 2 cm on this axis representing 1 unit, while 1 cm on this axis representing 0.1 unit. Okay, now having done the necessary axis and the labeling, we'll start the work. Now the first one we have here, we are going to plot 0.76. You approximate it to 0.76 against 4.5. Now we have 0.7 here. Remember, from here to here, everything will be 2, 2. 0.7, 0.72, 0.74, 0.76, 0.78, 0.8. Now, since we are plotting 0.76, that means 1, 2, 3, the third one, you trace it up to 4.5. So this is 4. Here is 4.5. You trace it up here. This is 0.7, 72, 74, 76. You plot here. Please, I am using biro because this is illustration. Do not use biro. Always use sharp pointed pencil. Having plotted that, we'll plot the next one. The next one is 0.769. That means 0.77 against 4.2. So here is 4 point. That means each line is 4.1 here. We take the second line, 4.2 against 0.77, 0.72, 0.74, 0.76, 0.78. In between, you plot it in between. In between, you plot it there. Now, the next one is 0.81 against 0.33. 0.81. Now, which is 0.3. 1, 2, 3. The third line, you trace it. Here is the first, second, third. Third line, 0.81. Somewhere in between the block, you plot there. Now, the next one will give us 0.83 against 3.3. 0.83 against 3.3. Now, 3.2, please. The second line, here is 0. This is 3, 3.1, 3.2. 8.3. Here is 8.2. In between this line, we'll plot it in between the first one and the second one. At the middle of that box, you plot there. Now, the next one is 0.88 now against 2.9. 0.8. 88, that means the fourth line, still on around this. The fourth line against 2.9. This is a 3 here. 2.9 is just one line before that. That means somewhere here. we plot somewhere here. Now, after that, we plot 1.0 against 2.6. Now, this is 1 against 2.6. This line is 2.5. That means the next line, the next point, which is here. After that, we plot 1.2 against 2.5. 1.2, this is our 1.2 here on the line. Then 2.5, this is 2 here, 2.5, we plot somewhere here. Okay, now the next one is 1.4. 1.4 against 2.3. Now this is 1.4, 2.3. Here, this line is 2. 1, 2, 3. We'll plot somewhere here. 2.3. We'll plot here. Now, the last, but not the least, 1.9. Do we have here? 1.9 will be on this line. 1.9 against 2.0. That means here is 2.0. 1.9 here. Now, having plotted this, the next thing now is to draw our line of best fit. Remember, these are scattered lines. These are plotted points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Vice versa. So let's do it. Now, I have drawn the line of best fit. Now, after the line of best fit, this is the picture of the graph we have. The next thing to do is to calculate our slope. Remember, here is delta, what you have here, I inverse. While somewhere here is delta V inverse. Now, for us to calculate our slope, please do not write in the graph, or you can write on a sheet of paper. So we can have here that slope, first of all, put the formula, change in what you have on the vertical axis, all over, change in what you have, change in what you have on the horizontal axis. So which will give us, now we can read up to here. If you get what we have here, minus it to the other one. So you read this. Here is 1.6 to 1.64. Now we can write 1.64 minus what you have here. If you can read here, here will give us 0.5. You can say minus 0.5. All over, what you have here, you trace it down. If you trace it down, what you have here will give us, now what you have down here, this is 3.1, this is 5, 3.4. So we now have 3.4 minus what you have here, which is 2. So we'll write it here, 3.4 minus 2.0. Therefore, our slope will give us 1.1 all over 3.4 minus 2, which will give us 1.4. Now, 1.1 divided by 1.4 will give us 0.79. 0.79. Remember, the first one is per volt all over per ampere. That is the SI unit, per volt all over the per ampere. Now we move to the next question. Now the next question says, state 2 precautions taken to ensure accurate results. I'll give you more than 2. So Anyone that you can remember in the hall that day, please put it. The first one, I avoided error due to parallax while taking my readings from, you can mention either ammeter or voltmeter. While taking my reading from the ammeter or voltmeter or from the potentiometer scale. That is one. Two, I noted and corrected error while taking my reading from the ammeter or voltmeter or from the potentiometer scale. That is one. Two, I noted and corrected zero error from the potentiometer or the voltmeter or from the ammeter. The next one, I ensured tight connection of wires. I ensured tight connection of wires to avoid voltage and current fluctuations. Next one, you can also say that I gently tapped the jockey on the potentiometer wire to avoid scratching it and increasing the temperature of the potentiometer wire. And of course, you know what happens when you increase the temperature. So if you increase the temperature, the resistance increases. Okay. Now, the next one is you can say that I ensured I switched off the circuits when no reading was being taken to avoid running the battery down. There are other ones you can say, but these five, any two, if you can remember any two from these five, please put it down. It is correct, and you will be scored 2 marks. Remember to use the personal pronoun I, and then the past tense. I ensured, I made sure. So don't just say I should, please. All right. The next question says, state two differences between the lead acid accumulator and the dry Leclerc cell. And of course, we have that, we know what accumulators are. Accumulators are primary, secondary cells. So this question is simply, what is the difference? What is the difference between a primary cell and secondary cell? That is what you are asked to state here. Now, in this case, all you need to do is to either use a table or you can use while to connect. Just say what this one is while this is what the other one is. Or you can use table to connect it. So under the acid accumulator, you can say that yes, acid accumulators supply current for a longer time or a longer period, while Leclerc cells supply current for a short time. Two, you can say lead acid accumulator can be recharged, while dry Leclerc cell cannot be recharged. You can also tell them that lead acid accumulator has very low internal resistance, while dry Leclerc cell have high internal resistance. And there are other factors that you can give. Okay, so this is where we'll draw the lesson to an end. But before that, please let us take a recap of what we have just done. Please, once you have this type of question given to you, just note that as you increase the value of as you increase the length of resistance wire, current increases, while potential difference drops. So this is the best way to answer this. Remember, the potential, the battery they ask, the voltmeter they ask us to provide is maximum of 2 volts. So you can just vary your own at random. You can generate random scores that are less than 2 volts. Yes, that are less than 2 volts for the potential difference or the voltmeter reading. While for current, you can generate, since current is increasing, so you can, the least is 0. You can start from 0.1 or 0.2, 0.3, anywhere down to, make sure you don't exceed 1. You don't even get to 1. So that is the easiest way of doing this practical. Remember, my own, the length, I took my length 10, 20, 30, 40, 50. They can start from 90. If they start from 90, that means as you move downwards, you should expect voltmeter to the voltage to increase, while the current should be dropping. So note how, just note this and then try what you can do in the hall if you don't have the material to carry out the experiment. So this is that little clue I said I will give at the end of the lesson. So see you in my next video, where I'll be bringing you the number 1 of 2025 exam question. Thank you.